Welcome to session 3, module 1. So next is hydropower plants are another important renewable source of energy is hydro energy. Hydro energy is renewed every year. So during the rainy seasons we receive the rain. The rain after it rains, the water flows in the form of rivers, and then for these rivers when we construct a dam across the flow, so that water can be stored, and that stored water is in the form of reservoir. So that stored water at a height, certain height, possesses some potential energy. So that potential energy possessed can be utilized to generate power. So this image or photographs shows the powerhouse wherein hydroelectric power is generated. It consists of a dam. Behind this there is a reservoir, and through the penstocks, these are pipelines which carry water, are called penstocks. Water comes through this pipeline. When it flows toward downward direction, it increases the velocity of flow and pressure also increases. That means the potential energy of the water is converted into kinetic and pressure energy. With that pressure and velocity, when this water comes and at the end of this penstock pipes, we locate a turbine. So when it strikes the turbine blades rotates with high velocity, high speed. Then whatever the energy, kinetic and pressure energy of water is converted into rotation, mechanical rotation of the turbine blades rotor. So that turbine rotor is connected to the generator and power is generated. So this is how a hydropower plant works. See in detail, this schematic explains the arrangement for a hydropower plant. So here this is the flowing river. It flows down, but at the top itself, before the water flows down in the river, we construct a dam. Then we store the water. It's a reservoir to store the water, and then that water is taken through a channel, open channel, and then this channel ends at a forebay. So it is again a small reservoir, and then through this, from this, the outlet is connected to the penstocks, which I told you in the previous slide. Penstocks, the pipelines which carry water. So then this forebay is required to maintain a constant and uniform flow of water through the penstocks. So then this penstocks ends at a turbine inlet of the turbine. When water strikes the turbine blades, rotors with high kinetic energy and pressure energy, that energy is transferred to the turbine blades. So thereby rotating the rotor of the turbine. Then this rotor is connected to the generator shaft, so which in turn rotates and then generates electricity. This is how the potential energy available here of the water is converted into kinetic energy and pressure energy while flowing through the pipeline, and at the end there is some another arrangement to increase the pressure and velocity heads or kinetic energy. Then the turbine rotates. In turn, it rotates the generator shaft. Generator rotates, so thereby generating the electricity. This is how a hydropower plant works. Okay, as I told you in the previous slide, in hydroelectric power plants, the potential energy of water due to its high location is converted into electrical energy. The total power generation capacity of the hydroelectric power plants mainly depends on the head of water and volume of water flowing towards the water turbine. So head means the height at which the water is stored. Okay, then amount of water stored depending on the two parameters, height at which water is stored and the volume, the amount of water stored. So depending on that we can generate the electricity. The capacity of the power plants depends on these two factors. Then if you take the working principle of hydroelectric power plant, as I told you, water flowing in the river causes two types of energy. So one is kinetic energy due to its flow, then potential energy due to its height. So potential energy of water is utilized to generate electricity. The potential energy of water stored at a height is converted into mechanical energy in the turbine. Before that, as I told you, the potential energy while flowing through the pipelines, penstock, is converted into kinetic energy and pressure energy. When it flows with high velocity inside the pipeline with the pressure of the penstocks, it converts potential energy converted into kinetic and pressure energy. That pressure energy and kinetic energy, when enters into the turbine, is transferred to the turbine rotors, so thereby converting into mechanical work. Work means here rotation of the rotors. So that mechanical work produced by the water turbine is converted into electrical energy in the generators. So after doing this useful work, water is discharged from the turbine to the river through a river. Huh? So through a tail race at the end of the turbine through which water is left out back to the river is called a tail race. Huh? So then next we move on to another renewable source of energy, that is wind energy. Wind energy is the energy contained in the force of the winds blowing across the earth's surface. So wind energy is defined as the kinetic energy associated with the movement of large mass of air over the earth's surface. So for that energy available in the blowing air can be utilized to rotate the blades, large blades of a wind turbine. It may be wind turbine or a windmill also. So depending on the availability of air velocity, geographical location, we can install either a wind turbine, or windmill. So here these are the blades which are exposed to the high velocity wind. So then that energy of the flowing wind, kinetic energy, is transferred to the blades and then the blade starts rotating. These blades start rotating. This rotation of the blade is connected to the central shaft. So it's a rotor. So then this shaft of the turbine is connected or coupled with a generator. So this generator rotates. The rotation of the generator again leads to generation of electricity. Generator purpose is to generate the electricity. Turbine purpose is to convert the wind energy into mechanical rotation. Turbine converts the kinetic energy of the air into mechanical rotation. This mechanical rotation is converted into electricity in the generators. This is how a wind turbine works. So wind energy is the indirect form of again solar energy. Okay, wind, the blowing of wind again is due to solar energy only. That is, so there will be difference in the pressures. So you have pressure of the air in the atmosphere, that again leads to the flow or rushing of air towards the low pressure area, thereby causing the wind to blow. So it is caused by the uneven heating of the earth surface by the sun. Okay. So if there is uniform globally, if it is uniform pressure, uniform temperature, then there was no any possibility of wind current and no possibility of rain, nothing. But because of the unevenness in the heating of the surface of the earth, at some places there is low pressure and some places high pressure in the air. So whenever there is low pressure to that area, air rushes from the higher pressure areas, so thereby creating wind current, the flow of air, which we call as wind blow. Okay. So in ancient times, the kinetic energy of the wind was used to propel ships by sails. You might have seen. You cannot say ancient. Some time ago, you might have seen these sailors used to use the wind current to sail across the sea. So even Vasco da Gama and all those people used such ships which they used um, by the kinetic energy of the wind. They used to sail by using those propellers. So they are not mechanical propellers, they are wind propellers. The wind turbines or windmills are used to convert the kinetic energy of wind into mechanical work, which may be converted into electricity in the generator. For the production of alternating current, windmill must be designed to operate at a constant angular velocity. The velocity of rotation of the windmills should be constant. So in order to generate alternating current with a definite frequency. Otherwise, because here the wide range of wind speeds will decide the frequency of the current. Therefore, so it is essential that we design it with a constant speed of rotation so that we can achieve a constant frequency. Mhm. Then when the wind blows, it rotates the propeller, which turns the generator to produce electricity. That's what I told you in the previous slide. Some of the generally used propellers for horizontal axis windmills are multi-blade type, sail type, and propeller type blades, which you can see here in the previous diagram. You have seen this. Then some advantages of wind energy or windmills. The wind is free and with modern technology it can be captured efficiently. So day by day we are improving the efficiency of these wind turbines. As, uh, Once the wind turbine is built, the energy it produces does not cause greenhouse gas or any other pollutants. So that means totally it is pollution free. Okay. So many people find wind farms an interesting feature of landscape. Okay. Then remote areas that are not connected to the electricity power grid can use wind turbines to produce their own supply. Remote areas, that too in the guard sections and all those things, in the rural locations where there is no power grid available, no power lines are drawn during those places. So we can install directly the wind turbine if wind is available, because there is some conditions. Say the wind velocity should be minimum 5 meters per second and above. Then only we can install the wind turbines, and it should be available in almost all the seasons of the year or days of the year. Otherwise, it will be a problem. So in that case, we can install these wind turbines in the local areas. So where we cannot draw the power cables and provide the electricity through grid, that's an advantage. So wind turbines have a role to play in both developed and third world. Okay. So then wind turbines are available in a range of size, which means a vast range of people and business can be used. This is about wind turbines. Next, we move on to another renewable source of energy. It's nuclear. It's not renewable. We can say non-conventional. Conventional. It's not conventional. It is non-conventional. The depletion of natural resources like crude oil, natural gas, coal has led to invention of alternative sources of energy. All these we are doing. Number one, these crude oil or fossil fuels are depleting day by day. The number two, they are leading to the pollution also, adding to the pollution. Therefore, it has become essential to find alternate source of energy. So in that way, this nuclear energy is again very neat, clean, non-polluting source of energy. So as you have studied, uranium is the main element required to run a nuclear reactor where energy is extracted. Nuclear fission or fusion process produce tremendous amount of heat energy. I hope you have studied all these things in your pre-degree courses. That nuclear energy, the energy stored in the nucleus of the atoms, especially it's there in all atoms, but these uranium and related elements which are radioactive, they can undergo easily this reaction, which is called a nuclear reaction, nuclear fission or nuclear fusion reactions. Hmm. Then when the reaction takes place, it releases a tremendous amount of heat energy. Heat energy released during the nuclear reaction is utilized to generate electricity. Okay. So how it is generated means again similar to thermal power plants, as I told earlier. Here, the heat energy is utilized to produce steam in the boilers. So then that steam is superheated and then it is used in the turbines to rotate the turbine blades, thereby generating the electricity in the generator. So nuclear fission is a process where heavy molecules split into two fragments of more or less equal mass. The nuclear fission reaction, the term itself says fission is dividing into two. Hmm? Heavy nucleus, uranium heavy nucleus divides into two almost equal fragments. So that is nuclear fission reaction. One more is, so this nuclear fission is the process of splitting a nucleus into two nuclei with smaller masses. Fission means to divide. As I told you, fission is to divide. Most common nuclear fuels are 235U means uranium 235. Not all nuclear fuels are used in fission chain reactions. What is chain reaction? A chain reaction is an ongoing series of fission reactions. Billions of reactions occur each second in a chain reaction. See here, why it is called chain means it is so one reaction leads to again continue with a few more reactions. See here a neutron which comes and strikes the nucleus, target nucleus. Then this nucleus divides into two smaller nuclei. Say this nucleus is uranium 235 nucleus. Then when this neutron comes bombard or strike this nucleus, this because this is very heavy, then it absorbs the energy and split into two. These are the this reaction is a fission reaction because it divides into two, and these are the fission products of the fission reaction, smaller nuclei. Okay. Then along with that it liberates few more neutrons. So then again each neutron, so in this case in this diagram you can see one neutron coming and striking the nucleus. Then it releases three. According to this diagram, there are three more neutrons. So these again neutrons go and strike another nucleus. Again leads to nuclear fission reaction. So this continues. This chain will continue. So such millions of reaction takes place within short span of time, and it is very difficult to control this reaction. So there are some techniques so through which we absorb these neutrons, thereby control this chain reaction. Okay, so on the Earth, nuclear fusion reaction takes place in nuclear reactors, which use controlled chain reactions to generate electricity. Here we are using. Uncontrolled chain reactions takes place during the explosion of atomic bomb. Okay, whatever we are doing, these nuclear reactions, it takes place in a enclosed reactor. So nuclear reactor, it is highly enclosed, so that is productive. Then the same uncontrolled reaction takes place, then it becomes a bomb, nuclear bomb. So uncontrolled chain reactions takes place during the explosion of an atomic bomb. Okay. Then this neutron plus heavy nucleus leads to fission reaction plus neutrons again to R3 plus energy is released. Our purpose is to release this energy. Okay, say 92U235 plus 1 neutron leads to 56 beryllium and so 56K chromium, krypton. Huh? So plus 20 neutrons plus energy. This is how the reaction takes place. The energy released by fission of 1 gram of uranium-235 is equal to that due to combustion of 50 million tons of coal. Uh, it is about 8.5 into 10 raised to 10 joules. It is actually. So just imagine by this nuclear fission reaction of 1 gram of uranium-235 energy released, heat released is almost equal to combustion of 50 million tons of coal. Such an enormous amount of heat is released during the nuclear reaction. So in the above reaction, uranium-235 is used as fuel. It is also called as fuel here. Even though it is not combustion, it's not burning, so it is called fuel because it undergoes the reaction. Reaction is nuclear reaction, splitting of nucleus into two. So nuclear reaction. So uranium-235 is used as fuel, which is available in nature. Okay. The other reactor fuels are uranium-233 and plutonium-239, which are prepared artificially. U-35 is available in nature, natural. Then uranium-233 is prepared because in order to improve the efficiency of reaction and to control the reactions as per our requirement, we make some alterations in this 235 and prepare U-233 uranium. And also nowadays this plutonium is becoming popular in nuclear fuel. Okay. Next, this is how the nuclear power plants work. This is how the nuclear power plants work. So this closed chamber, this is called a nuclear reactor. So this is highly enclosed because during the reaction, the radiation liberated, generated should not pass through this. If we are exposed to this radiation, it leads to a lot of health problems, maybe human or any other animals. If we are exposed to this radiation, leads to a lot of health issues. So therefore it is to be the reaction, nuclear reaction is to be conducted in a closed chamber, which we call as a nuclear reactor. This reactor does not allow the radiations after the nuclear fission reaction. Whatever the radiation coming out, they are stopped or blocked or absorbed in this. No radiation can escape through this. It is a closed, sealed, shielded reactor. Okay. So inside this, the reaction takes place. Okay. So the vertical lines, what we see, they are fuel moderator. So moderators are used to control the reaction. Then So after the nuclear reaction, fission reaction, a lot of heat is generated. So that heat is absorbed by passing a liquid, usually hard water is said. So liquid is passed through, it acts as a heat exchanger here, it absorbs the heat and the steam comes out. High temperature water comes out here. Okay, this is one circuit. This circuit, water circuit is heavy water circuit. Heavy water circuit, so which enters at low temperature, absorbs heat, get heated up and comes out at high temperature. Okay, then this is another water circuit wherein water is pumped, and this is again a heat exchanger which exchanges the heat from this circuit, heavy water, to this water. Okay, so here heat is lost by this water and heat is gained by this water. So this temperature reduces and again pumped back to the reactor. But this water, low temperature enters and it gets heated up and becomes steam. The steam is taken out here and it is made to expand in the turbine. So this steam is with high pressure, high velocity steam enters into the turbine, strike the turbine blades with high pressure and temperature. Then energy is transferred from the steam to the rotor blades of the turbine. So then the turbine rotates. Then low temperature, low pressure steam comes out here and that is cooled in the condenser. Again water is pumped. It's continuous. Okay. So then here when the turbine rotates, it is connected to a generator. Generator generates electricity and it is supplied. Okay. Working is very simple. It consists of one nuclear reactor. So where reaction takes place, huge amount of heat is generated after the reaction. Then two circuits, one circuit for exchanging the heat from the nuclear reactor to outside, heavy water circuit. Then another circuit, hot water. So here it enters at low temperature, absorbs the heat from this, it's the heat exchanger. Then high temperature, high pressure, steam comes out. That steam expands in the turbine, then transfer the energy to the turbine rotors. Then low temperature, low pressure steam comes out, condensed, made again to water, then supplied back. This continues. So this is how a nuclear power plant works. I hope it is clear for you. So this is what I told you, the same thing. Here control rods made up of material that absorbs neutrons. As I told you, so it is uncontrollable reaction, chain reaction, nuclear reaction, fission reaction. Therefore, in order to control that rate of reaction, we use control rods. They are nothing but the rods which absorb the neutrons. Okay. So thereby reducing the number of reactions, thereby controlling the reaction. They are inserted into the bundle using a mechanism that can raise or lower the control rods. Control rods can be raised or lowered because that position of the rods in the reactor decide the absorption rate. If it is too low in depth, then entire rod is exposed for absorption. The reaction will be very low that way. So the control rods essentially contain neutron absorbers like boron, cadmium, or indium. Okay. So then steam generator, as I told you, this is the heat exchanger which exchange the heat between heavy water and soft water. So after this absorbing the heat, so this becomes steam, high temperature, high pressure, steam goes out. Then after losing the heat, this is low temperature, heavy water comes again into the reactor. This is how it continues. I hope it is clear. Then the coolant pump uh, pressurize the coolant to pressures of the order of 1.5 bar. The pressure of the coolant loop is maintained almost constant with the help of the pump and a pressure unit. The pump is very much essential, required for circulating the water into this, because naturally it doesn't flow. You have to pump at a constant fixed flow rate, both here and here also, depending on the temperature available here, then depending on the temperature available here, and also depending on the turbine and depending on the power to be produced, a requirement or demand in the grid. Then feed pump are required to feed the water to the heat exchanger. Condenser is to cool the steam, low temperature, low pressure steam coming out of the turbine. Condensing is nothing but converting the phase from vapor to liquid. Steam coming out here, low temperature, low pressure steam, then loses the heat and becomes water after condensation. Then it is pumped back. This is how it works. Then advantages. Nuclear power generation does not does emit relatively low amount of carbon dioxide. Okay, cannot say no, but the amount is very less. Huh? Actually, in this reaction, there is no any CO2 emission. Hmm? But it emits in the other way. Hmm? The emissions of greenhouse gases and therefore the contribution of nuclear power plants to global warming is therefore relatively very less. This global warming again because of the greenhouse gas is CO2, CO2 emission in the reaction is almost no, therefore global warming is less or no due to nuclear power plants. This technology is readily available, it does not have to be developed. Okay. Then it is possible to generate a high amount of electrical energy in one single plant. That's the advantage. Drawbacks are many. Problem of radioactive waste is still an unsolved one, because after the reaction, that waste produced, uh, that's what I told you during fission reaction, it is split into two. Then after the reaction, that waste, nuclear waste, disposing that itself is a very big problem, because it is highly radioactive. Radiation emitted is highly dangerous for the human health. So high risk. It is technically impossible to build a plant with 100% security. There is every possibility of leakage of radiation, and if in case of accident, it will be a very big issue. The energy source for nuclear energy is uranium. Uranium is a scarce resource. It's not available in plenty. Hmm? Its supply is estimated to last only for next 30 to 60 years. The available resource of uranium on this planet Earth is very limited, and if we continue to use at this rate at which we are using, it will be totally exhausted in 30 to 60 years. So we have to think of other technologies. These are some drawbacks. So with this, I will conclude the session 3 of module 1. Thank you.